Hey, let's talk about circles today. Now, I'm sure you know what a circle is, what it looks like, but did you know that actually all points on the circle are the same distance away from the center? Yeah, you probably did. That's called the radius. Now, we're typically concerned with graphing things on the xy plane and finding equations for them, so that's exactly what we're going to do for this circle. Let's label the center because it's an important point, and let's give it some coordinates. Let's say h and k. So that's what we're going to call the center, h comma k. And the radius, let's just call that r for radius. Now what we were saying before is that the distance from the center, which is the point h comma k, to any random point on the circle, let's call that random point x comma y, that distance is the radius, which we're calling r. Now if you remember your distance formula, do you? Do you remember the distance formula? Well, let's see how that goes here. Let's find the distance between the point hk and the point xy. That should look familiar, right? That is the radius, because remember, the radius is exactly the distance from the center of the circle to any point on the outside of the circle. And if we square both sides, that square root is going to go away on the right-hand side there. And then let's just rearrange it, so let's move the x and y's over to the left side and the r over to the right side. Just swap the sides. So it looks like this. This is what's called the standard form for a circle. So this is our, actually, equation for the circle. Alright, lots of numbers flying around here, lots of letters. Let's actually do an example. Let's use this standard form of a circle, and let's actually find the equation of this particular circle. So we know that we need to find the center. Pretty easy to find in this example. It's -1, 2. So that actually means something about what h and what k are. H is -1 and k is going to be 2. What's the radius now? Well, the radius is the distance from the center to any point on the circle. I'm actually going to be clever about how I pick this, how I draw this radius here. And if we draw it from the center straight down to the point -1, 0, you can see that that distance is actually 2. So we're ready to plug everything in to our standard form. So h is going to get replaced with -1, but that minus h turns actually into a +1 because you're minusing a -1. And then the minus k portion turns into -2. Everything's good there, and the radius is 2, so we plug that in. And then let's just rewrite it down here. There we go. Now you can actually expand this and see what happens. So x plus 1, that whole quantity squared, you can expand that or FOIL it, whichever you prefer, and that's what you would get. Same with the y minus 2 quantity squared. And then you can group all the terms together, combine the common terms, see what happens. This is called the general form of a circle. Notice it looks a lot different than the standard form of a circle, but they both mean exactly the same thing. They both describe this circle. So let's see if we can take a circle that's written in general form and convert it into the standard form so that we can just read off the center and the radius of the circle. Here's how we're going to do that. We're going to group all of the x terms together, and we're going to group all the y terms together, and then we're going to subtract the constant over to the other side of the equation. I left a little bit of room here after the x terms and a little bit of room after the y terms for what we're about to do, which is called completing the square. So this process, what we're going to do is we're going to take the coefficient in front of the x, which is -6. We're going to divide it by 2 and square it. That number is 9. And we're going to add 9 to both sides of the equation. That's why I left a little room there. Now be careful, you have to do this to both sides of the equation, otherwise you violate that it's actually an equation, an equal sign. You have to do it to both sides. So let's do the same thing here, completing the square, with the y terms. So we're going to take the 4 which is the coefficient in front of the y, divide it by 2 and square it. Turns out to also be 4. Let's add that to both sides of the equation. Now how does this help? It's the exact same equation, it just looks a lot different. Here's what we do. Group together the x squared minus 6x plus 9 and use your factoring skills. And I bet you can factor this. I bet you can also factor the y squared plus 4y plus 4. Here's how they factor. And then, of course, negative 3 plus 9 plus 4 is 10. So that's where that came from. The trick of completing the square helps you turn this general form of a circle into this nice looking standard form, where we can now just read off the center and the radius. Remember, the standard form is written right here. So the h is actually 3, and the k, be careful, is negative 2. So the center is 3 comma negative 2, and the radius, well, the radius squared is 10, so that means that the actual radius is the square root of 10.